and multiplying a whole number by a fraction using the associative property. The only difference is how we're going to represent our answer. So please pause, read the definitions to yourself because I'm not going to read them today since we've already seen them before. So again, pause now and press play when you're ready. You've already read the definitions. All right, so our first problem, 40 times 2/6. So if you remember from our last video, I'm just multiplying this whole number times the numerator, and then I keep my denominator. So technically what I'm doing is 40 times 2 over 6, and I get, well, 40 times 2 is 80 sixths. Now, the difference today is that we're going to not keep this improper fraction. We want to convert this into a mixed number. So there's two ways to do it. I can do long division, so I can divide 80 by 6. 6 goes into 80. Well, 6 goes into 8, because I know 6 can go into 8, so I'm not going to do into 80, just 6 into 8 one time, and that is 6. One group of 6 is 6. 8 minus 6 is 2. Then I bring down my 0. I now have 20. 6 goes into 20 3 times, because 6 times 3, right, I'm multiplying this, my divisor, by the numbers up here. 6 times 3 is 18. 20 minus 18 is 2. Nothing else to bring down, so this is my remainder. So now how I interpret this, 80 divided by 6 is 13 wholes, a remainder of 2, and that 2 is part of my fraction. 2 out of 6, or 2 sixths. So 13 remainder 2 is 13 and 2 sixths. The other way is to skip count by these sixths until I get to 80 sixths. Well, 6 sixths is 1 whole, 12 sixths is 2 wholes, 18 sixths is 3 wholes, 24 sixths, 4 wholes. If you notice, I'm just doing the multiples of 6, right? 30 sixths is 5 wholes, 36 sixths is 6 wholes, 42 sixths is 7 wholes, 48 sixths is 8 wholes, 54 6 is 9 wholes. I'm going to go down here just so I don't run into my long division. 60 sixths is 10 wholes. 66 sixths is 11 wholes. 72 sixths is 12 wholes. 78 sixths is 13 wholes. And I'm going to stop here because I'm only trying to get to 80. If I do another sixth, if I add another whole, I'm going to end up at 84 sixths, and that's too much. So to get from 78 sixths to 80 sixths, I only need 2 more sixths. So if you notice, I still have 13 wholes and 2 sixths, so I still get 13 and 2 sixths. So let's try one together. 34 times 2 eighths. So like I said before, this is the same thing as 34 times 2 over 8. So what would this equal? So first you have to multiply 34 times 2 and then represent it over 8. Well, if I were to multiply this using standard algorithm, 2 times 4 is 8 and 2 times 3 is 6. So hopefully you got 68 eighths because I keep my denominator. So 68 eighths, now this is where we have to convert this improper fraction into a mixed number. So we can try both ways. So let's first divide. 68 divided by 8. So I have to think, how many times can 8 go into 68? Well, it's actually 8 times, because 8 times 8 is 64. So now I can subtract. 68 minus 64 is 4. There's nothing to bring down. So my final answer is 8 remainder 4. So now this is how I'm going to make this and turn it into a mixed number. 8 is my whole number. 4, my numerator becomes my numerator. Sorry, my remainder becomes my numerator. That's what I meant to say. And then I keep my denominator of 8. 8 and 4/8. The other option is, like I said before, to count by eighths. A little trick so that you don't have to count all the way up is think of the highest number you can possibly remember when you're thinking of counting by eighths, or 8/8, meaning wholes, right? One whole. So as close as I can get to 68 that I can think of, well, let me say 48, because I know that 5 times 8 is 40. So I know this is 5 wholes, so I'm going to keep going from there. 48 eighths would be 6 wholes. 56 eighths would be 7 wholes. 64 eighths would be 8 wholes. And then 64 to 68, I'm only 4 away, so I'm just going to need 4 more eighths. So 8 wholes and 4/8, which is exactly what we got here. So go ahead and try this one on your own. Please grab a paper and pencil if you don't already have one. And press play when you're ready to check your work. Again, pause now, grab something to solve this problem, and press play when you're ready to check your work. All right, so we have 11 times 2/3. Well, that's the same thing as 11 times 2 over 3, or 11 times 2 divided by 3. That becomes 22/3, or 22 divided by 3. Well, 3 goes into 22 7 times, because 3 times 7 is 21. So I have 3 times 7, that's 21/3. I need one more to get to 22, so I'm only going to have 1/3 left over. I can still divide like I've been doing before, and I'm going to get the same thing, and I'll show you that now. 3 goes into 22 one time, oops, sorry, 7 times, and I get 21, because 3 times 7 is 21. Subtract 22 minus 21 is 1. 7 remainder 1. So 7 becomes my whole number, the remainder 1 becomes my numerator. And the same thing if you were to skip count. 3/3, 6/3, 9/3, 12/3, 15/3, 18/3, 21/3, and then I would need one more to get to 22. So if I count this, 1, 2, 3, 4, 5, 6, 7 wholes and 1 extra third. So pause again, try this last one. Please pause now and then press play when you're ready to check your work. Again, pause now and press play when you're ready to check your work. All right, well, 23 times 3/5 is the same thing as 23 times 3 over 5, or 23 times 3/5. So if I rewrite this as a standard algorithm problem, 3 times 3 is 9, oops, and 3 times 2 is 6, so 69/5. So 69/5. I prefer to divide. You don't have to do this, but I'm just going to show you this way. And if you did skip count by fifths, that's fine too. 5 goes into 6 one time. That's 5. One group of 5 is 5. 6 minus 5 is 1. Bring down the 9. So I have 19 now. 5 goes into 19 3 times. 5 times 3 is 15. 19 minus 15 is 4. So I have 13 remainder 4. My quotient becomes my whole number, and my remainder becomes my numerator. So 13 and 4/5. So I'm not going to do the skip counting strategy. Either way, you will still get 13 and 4/5. You determine as always which strategy works best for you when you're trying to convert the improper fraction back to a mixed number. Thank you so much, and as always, please contact me on Google Meet, Chat, Schoology, or Google Classroom if you're having any trouble. Thanks.